Hi, everybody. This is Chapter 14, Independent Samples T-Tests. So far we've talked a lot about the different kinds of T-tests. Let's go ahead and review where we're at. So, T-tests compare two groups. You're comparing one thing to another. One, two groups. So for example, in a single sample T-test, we compare our mean, that's one group, to the population, that's the other group. Okay? A paired samples T-test compares the same people at time 1 and time 2, so the two time periods of the two groups. The independent samples t-test compares two independent groups that have nothing to do with each other. So if I've got one totally different group from another totally different group and I want to know the difference, that's when I use an independent samples t-test. In fact, an independent samples t-test is probably the one that we use the most in psychology because when you run an experiment, if you want to know the difference between a control group and an experimental group, you're going to use an independent samples t-test. Now, keep in mind, whenever we're talking about an independent samples t-test, we are talking about two variables, but that's not the same as the two groups. So the two variables are the independent variable and the dependent variable. The independent variable is split into two levels, two groups. Here is an example. When we use an independent samples t-test, we're comparing two groups. So if you look at the data here, we are looking at one variable, which is your major, and another variable, which is your happiness. Major is one variable, happiness is the other variable. So a categorical variable is the independent variable in a t-test. The dependent variable is continuous. We are comparing two groups, psychology majors and business majors. The two groups are levels of one variable. The variable is major. The two groups are psychology and business. So the two groups we want to compare are psychology majors and business majors. Two groups, but they're in the same variable, and that variable is major. So for example, if you look at this, X is the variable that we care about, right? So in this particular case, we're looking for X is the happiness overall, right? For everybody, all majors. So that would n equal 4, right? 1, 2, 3, 4 different people in the whole group. We're now distinguishing capital N from lowercase n. When we talk about x sub 1, now we are talking about happiness. Happiness is x. Happiness is x. And x sub 1 is happiness for psychology majors only. So x sub 1 means we're looking for the dependent variable x in one of the levels. So that is psychology majors. The n is 2. I have one psychology major. Participant number 1 is a psychology major, and participant number 3 is a psychology major. There's two of them. So this lowercase n means the subgroup. N, capital N, that's everybody in the sample. Lowercase n is the subgroup in this particular case. So when we look at this, X sub 1 means we're talking about happiness scores just for psychology majors. The sub 1 is the first group, psychology majors. X sub 2 means business majors, so we're looking at X, happiness, for the business majors only. So we have X sub 1, psychology major number 1, psychology major number 2. X sub 2, business major number 1, business major number 2. So when we're looking at an independent samples t-test, now we are looking at one variable that can be separated into two levels. One variable, major, that can be separated into two levels, psychology and business. We are looking at the difference that they have on their happiness score. So my hypothesis might be, I think that psychology majors are happier than business majors, right? Psychology majors is one group, business majors is the other. There are two people who are psychology majors, so n is 2, meaning lowercase n is 2. Two people are business majors, so the n, or n sub 2, is 2. The sub then is the different group. Sub 1, psychology majors. Sub 2, business majors. So what that means is that what we're really trying to do, if I think that psychology majors have more happiness than business majors, I'm looking at the mean of the first group. So X bar sub 1 means the mean of psychology majors. The sub 1 is the psychology majors. X bar sub 2 is the mean of the business majors. So what I want to know is the mean for psychology majors, the mean happiness for psychology majors, significantly different than the mean happiness for business majors? The sub is the subgroup, right? The sub then in this case means sub 1 means psychology majors, sub 2 means business majors. When we look at this, you'll figure out that X bar sub 1 equals 6. Well, how did I get that? Well, X bar sub 1. Sub 1 means psychology majors, so I want to know the mean happiness just for psychology majors. So how many psychology majors do I have? 1, 2 of them. This one has a happiness of 4. This one has a happiness of 8. 8 plus 4 is 12. You divide by 2 because remember, lowercase n sub 1 is going to be 2. Then I get 6. 12 divided by 2 equals 6. X bar sub 2, you do the same process. X bar sub 2 is the mean of business majors. Sub 2 is going to be the second group, business majors. So 6 plus 4 equals 10 divided by 1, 2 divided by 2. 10 divided by 2 equals 5. And what I'm really trying to do in an independent samples t-test is I'm trying to see, is there a significant difference between one group and the other? So I look for X bar sub 1 compared to X bar sub 2. That is, the mean of one group compared to the mean of the second group. When we do that, then we can figure out T. So what I want to do now is I want to look at the formulas that we've had for the paired samples t-test. And you remember that all of the formulas from the Z to the T, they work together. Z is for populations and T is for samples, and normally is the way we work. Now, if you remember, when we were looking at the paired samples t-test, so this top equation is for the paired samples t-test from the last chapter. If you remember, we were looking at the D bar. D bar is all the differences and the mean of all the differences, okay? Minus 0 over the standard deviation of D bar. S sub D bar is the standard deviation of all the D bars, all the mean differences that could happen, okay? Now, the reason why I want to show you this is because we want you to show how all of the t-tests really work. We look at what we got, the mean difference, minus the null hypothesis. So if there's no difference, then I would expect there would be 0, right? My mean difference is what I think there is a difference. And if null is true, then the mean difference would be 0. So I take what I got minus what I would expect if the null is true. In the same way, you'd say X bar minus mu, because mu is what we'd expect if it's the same as the population. Well, we're doing the same thing here. This is the formula for an independent samples t-test. And remember what we're doing is we're looking for X bar sub 1 minus X bar sub 2. So this is the difference between the two groups. Remember, sub 1 is psychology majors, sub 2 is business majors. So the difference between psychology majors and business majors is X bar sub 1 minus X bar sub 2. Now over here, we look at what the mu would be between the two groups in real life. Now, if there's no difference between psychology majors and business majors, then mu sub 1, the mean of all psychology majors, minus mu sub 2, the mean of all business majors. If there's no difference, then this also equals 0. And what you see down here is the standard deviation of X bar sub 1 minus X bar sub 2. So this X bar sub 1 minus X bar sub 2, that is a sub, right? That is the distinction. It is not the standard deviation of X bar sub 1 minus the standard deviation of X bar sub 2. It is the standard deviation of all possible X bar sub 1 minus X bar sub 2s. Specifically, it looks like this. Remember, for the paired samples t-test, we took the standard deviation of the difference divided by the square root of n. Well, in this case, the standard deviation of X bar sub 1 minus X bar sub 2 is the square root of each of the variances divided by its n. So this s squared, the standard deviation squared, is the variance, remember? And remember, sub 1, that means psychology majors. So this is the variance of psychology majors divided by n sub 1. And remember, sub 1 is psychology majors, so the total number of psychology majors. So all I'm asking here is the variance of psychology majors divided by the number of psychology majors, plus the variance of business majors divided by the number of business majors. You add those together, you take the square root, that gives you the bottom half. Now, if we put all these things together, then here's what we get. T is going to equal x bar sub 1 minus x bar sub 2. Now, I got rid of the mu sub 1 minus mu sub 2. I got rid of that because that's going to equal 0. If there is no difference between psychology majors and business majors, then that's 0. And just like with the other one, we'll just get rid of that. Okay, so this is going to be the mean of psychology majors minus the mean of business majors divided by the variance of psychology majors divided by the number of psychology majors plus the variance of business majors divided by the number of business majors. You take the square root of that whole thing, and then we get an independent samples t-test. So here's what I want you to do. Let's work on an example. Calculate t for for this particular example. Okay, so in order to do this, let's go ahead and do everything we need to do. I've got a psychology major, business major, psychology major, business major, 4684. So I'm actually going to pull up this is not the one I want, this is the one I want. Okay, I'm going to pull up an Excel sheet and we're going to put it all here. So here's the participant, and we're going to get their major, and then we're going to get their happiness. So, for example, this participant number 1, is a psychology major, and their happiness level is 4. Participant number 2 is a business major, and their happiness is 6. Participant number 3 is a psychology major, whose happiness is 8. Participant number 4 is a business major, whose happiness is a 4, right? Yep, 4. Okay. This is the independent variable. This is the dependent variable. There are 2 levels, psychology major and business major. Those are the 2 levels. And what this is asking us to do then, let's go ahead and you can see it here. Whoops. There. We're going to get x bar sub 1 minus x bar sub 2 divided by the variance sub 1 variance sub 2. So what I'm going to do is I'm going to split happiness by psychology and business majors. So here's the way I'm going to do this. Let's go ahead and look at psychology majors. The psychology major's happiness. So this psychology major had a happiness of 4, and this one. So now I'm listing it in a column instead of in the rows like this. And this psychology major right here had a happiness of 8. So these are all the happiness scores for the psychology majors. Then the same thing for the business majors. Let's go ahead and do it right here. This is the same data, so I'm just doing the same data right here. Business majors, this first one had a happiness of 6, so I put a 6 right there. This one has a happiness of 4, so put a 4 right there. When I look at the means, then what I'm looking for is the mean of these 2, and then the mean of, those 2. So the mean of psychology majors is 6. This is x bar sub 1 because psychology is sub 1. 5 is x bar sub 2. It's the mean of the business majors. Sub 2 equals business majors. So the n, lowercase n, for each group is 2. Look, because I have 1, 2 of them. And for this one, it is also 2. 1, 2 of them. So if I need to figure out my t-score, there's several things I need to figure out. The first is we better figure out what our variance is supposed to be. So let's go ahead and get our variance. I'm going to do this the old-fashioned way by looking for the deviations and squaring those like we've done in the past. So for psychology majors, the deviations are going to be x minus x bar, right? And this deviation is going to be x minus x bar right there. Okay? Then we square those. Whoops, that was an x bar. I'm sorry. Yeah, I did it wrong both times. Look at that. So do the deviations then. It's x minus x bar. And then, again, this is going to be x minus x bar. There we go. The deviation squared, just like we always do, is this squared and this squared. When you add those two together, you get the sum of squares. So this is the sum of all the deviations squared right there. And then the variance, because the variance is what we want. We really don't even care about the standard deviation because S squared, the standard deviation squared, is the variance. So variance is going to be this divided by n minus 1. N minus 1, well, I have 2 people in this group, so n minus 1 is 1. You're going to get 8. Let's do the same thing then for our business majors. So we've got the deviation, which is x minus x bar right there. Okay. And then this is x minus x bar right there. So let's go ahead and make sure that we can see all this. These are the means. And this is n. Okay. The mean is 5, n is 2. The deviation is, let's make sure we got the right one. It's minus x bar, and then I didn't do that one right. This is x minus x bar. There we go. Deviation squared, this is going to be pretty easy, equals this squared, which is 1. That's going to equal 1. The sum of squares, means 1 plus 1 equals the sum of these. Guess what? It's going to be 2. And then variance is 2 divided by n minus 1. N minus 1 is 1. And so it's going to be 2. So now we have everything that we need. So let's go ahead and figure out all the stuff. I'll move this over a little bit so we can see it a little bit better. We can get the information that we need. So first, let's start with x minus x bar. The mean for psychology is 6. That's x bar sub 1. The mean for business is 5. That's x bar sub 2. So x bar sub 1 minus x bar sub 2 equals 6 minus 5. And that is going to, whoops, I think I'm in something else. X bar sub 1 minus x bar sub 2 is going to be the mean of psychology minus the mean of business. 6 minus 5, that equals 1. Now, let's work on this thing right here. The variance of psychology is over here. This is the variance of psychology majors. It is 8. The variance of business majors is 2. 8 divided by 2 is this one. So variance divided by n, 8 divided by 2 is 4, plus variance 2 divided by 2 is 1. So this is going to be 5. And then we need the square root of 5. So remember, variance of the first group divided by how many people. So the variance of psychology majors divided by the number of psychology majors. Variance of business majors divided by the number of business majors. So in this case, it's 8 divided by 2, that's 4, plus 2 divided by 2, that's 1. So 4 plus 2 is 1. So this is going to be square root of 5 that we're going to get. So equals that. We take x bar sub 1 minus x bar sub 2 divided by that whole thing, and we get our t. T is this. .447. Now, the next part, of course, is going to be to figure out the degrees of freedom and whether or not we're going to reject or fail to reject the null hypothesis. So this is the example we just barely did. The degrees of freedom for an independent samples t-test is n sub 1 plus n sub 2 minus 2. So you take the number of people in the first group plus the number of people in the second group minus 2. And that's almost always n of everybody, right? So take the big N minus 2. That's what you're looking for. So in this particular case, we had 4 people. So we had 2 psychology majors plus 2 business majors minus 2 equals 2. The degrees of freedom is going to equal 2. So let's go ahead and look at our table right here. If our degrees of freedom is 2, then that means that we need to look in, this is not a very good way to do this. We need to look in this row. I'm underlining, at least I'm trying to. In fact, I'll even circle it. Not very well. So we're looking in that second row. Degrees of freedom equals 2. Let me get rid of that because I can't see anything. There we go. Degrees of freedom is going to equal 2. So we're looking in the second row. All right. If we're looking in the second row, let's assume that we're doing a two-tailed test. The two-tailed test with degrees of with alpha equals 0.05, and degrees of freedom is 2 equals 4.303. That's our critical value. That means we've got to get a t-value that is that or more extreme. And we've got like a 0.4, let's see what it was that we calculated. We calculated 0.447, a 0.45. 0.45 is way over here. That's really close to equal. We have to fail to reject the null hypothesis. So here's what we want to do next. Let's go ahead and take a look at a new example, and you calculate it and see if you can get it. So this, I have a hypothesis that the generation you're from will affect how many CDs you own. So I think that the generation you're from is going to affect the number of CDs, right? So let's keep it two-tailed, okay? Two-tailed with alpha equals 0.05. And I've got millennials versus boomers. So what you're trying to do is see, is there a significant difference between the number of CDs that millennials own compared to the number of CDs that boomers own? Go ahead and calculate the T. Now that you calculated the T, go ahead and see whether or not we're going to reject or fail to reject the null hypothesis. Okay, so with this, let's go ahead and calculate it. That's not the right one. This is the right one. Okay. So I already entered the data right here. What we need to do then is we need to figure out our different groups. So let's have millennials be sub 1 and boomers be sub 2. So we're going to do it just like we did before. Let's go ahead and expand this so that we can see. And let's make millennials. Millennials will be here. And the first millennial had 3 CDs. Participant number 3 is a millennial. They had 5 CDs. Participant number 5 is a millennial, has 8 CDs. Participant number 7 is a millennial, has 4 CDs. Boomers. So participant number 2 is a boomer and has 10 CDs. Participant number 4 is a boomer and has 12 CDs. Participant number 6 is a boomer, has 6 CDs. Participant number 8 is a boomer and has 18 CDs. When we look at the means for each of this, then we find out that the average number of CDs owned by millennials is 5, whereas the average number of CDs owned by boomers is 11.5. We're trying to figure out, is there a significant difference between 5 and 11.5? So let's go ahead and calculate the variance just like we did before. So we're going to insert each of these. We're going to make some space, make sure we've got enough room. So this is going to be the deviation. Deviation is x minus x bar. Okay? Now in this particular case, let me just go ahead and do this so it's easy for me. I'll just tell it, whoops, to do this for all of it. Right there. These are all of our deviations. And these are going to be our deviations squared. So this is deviation squared. When we add those up, we get the sum of squares. The sum of squares is the sum of all of these deviations squared. And the variance then is this divided by n minus 1. So we have 1, 2, 3, 4. 1, 2, 3, 4 millennials. So n minus 1 is 3. We get a variance of 4.667. Let's do the same thing for the boomers. We get the deviation. The deviation is x minus x bar sub 1, which is 11.5, H6. H6. Let's go ahead and I'll add an inserted variable here so you can see it. There we go. So this is the mean, x bar sub 2, okay? And then we get one for each of these. Okay, great. Now, we look at those, and those are our deviations. Now we need the deviation squared is, whoops, is this squared. We do all of them, and we get this. Let's get rid of that one, because that doesn't exist. The sum of squares then is the sum of those. Then the variance is 75 divided by n minus 1. So equals this divided by, there are 4 boomers, minus 1 is 3. So 3, and you get 25. That's our variance. Okay, so when we look at all of these, we need to figure out, x bar sub 1 minus x bar sub 2. So that's going to be x bar sub 1 is 5 minus x bar sub 2, 11.5. So that's going to equal 5 minus 11.5. X bar sub 1 minus x bar sub 2. Then we are going to get the variance divided by n for each one of these. So for millennials, that's going to be the variance for the group of millennials divided by the number of millennials, which is 4. And then for the boomers, it's going to be 25, the variance, divided by the number of boomers, which is 4. And then you add those two together. You get that. You take the square root of that. Whoops. It's just the square root of that right there. And when you get the t is going to be x bar sub 1 minus x bar sub 2, which is negative 6.5, divided by all of that we just square rooted. Negative 2.387. Now, when we look at negative 2.387, which is about negative 2.39, we got to look at to see whether or not we can reject or fail to reject the null hypothesis. So to figure this out, we look at the table. There are in total 8 people. So 4 boomers, 4 millennials. That's 8 total. And then we minus 2. So we get 4 plus 2 is 6. Our degrees of freedom is 6. Okay? If alpha equals 0.05 on a two-tailed test, then our critical value is 2.447. 2.447. Now, it doesn't matter if it's positive or negative, right? 2.447 for the positive, negative 2.447 for the negative side. It's symmetrical. We just calculated a t-statistic of negative 2.38. Negative 2.38. And when we look at this, negative 2.38 is not as extreme as negative 2.447. So we fail to reject the null hypothesis. What it means is negative 2.447. 2.447 is here. That's negative 2.47. And 2.38 that we calculated is here. So we have to fail to reject.